Hi Gomes graduates! In this video I'm going to read you the word problems from pages 27 and 28 in your packet, and we will do a little discussion of what we would need to do to solve them. Okay? Alright, number 1. Jim mails one package that weighs 3/8 of a pound and another package that weighs 2/3 of a pound. What is the total weight of both packages? So you know I like to think in pictures when I'm doing word problems. So I'm picturing a package or a box that weighs 3/8 of a pound and another package or a box that weighs 2/3 of a pound. Now the question says, what is the total weight of both packages? Well, if I'm finding the total weight of both packages, what would I need to do? If you said add, you are correct. We're finding the total. We're putting these two weights together. So we are going to add 3/8 plus 2/3. Okay? Now, we're not going to solve it here, but I'll give you a little hint. If you're looking at these two fractions and thinking, how could I solve those? They have unlike denominators. You are correct. They do, and you need to find a common denominator before you can solve them. So if you don't remember how to do that, there is a video on our Triple G5 website, our YouTube channel, on how to find common denominators so that you can add these two together. Number 2 is a little trickier. First of all, because it has more steps, and second of all, because it's that tricky kind of word problem that asks us for how much more. So let's read it. Rosa needs 5 1/4 yards of ribbon for a crafts project. She already has 2 7/8 yards of ribbon. How many more yards of ribbon does she need to buy? Now this always confuses us because when we hear more, we want to add. But let's think about what it's really asking us. She needs 5 1/4. So I'm going to kind of set up a line. I need this much ribbon. Think about ribbon, a little strip of prettiness, okay? So here's my ribbon. I need 5 1/4 mixed number to complete my craft project. I need that much. I have 2 7/8, so I don't have enough ribbon yet, but I have about to here. So I have this much ribbon. I already have 2 7/8, another mixed number. Can you see those? Okay. So I have 2 7/8. I need a total of 5 1/4. I have this much. So what I really need, what more I need is this missing piece right here. When they're saying how much more does she need, we need to figure out what this missing piece is. This kind of looks like some of the problems that we set up in the beginning of the year, if you remember that. You'd have the total part of it. How would we figure out the other part of it? Well, one way you can think about it is 2 7/8 plus some missing number, this missing part right here, is going to equal 5 1/4, okay? But if you're not sure, how would I solve this? You can turn that fact around and instead say 5 1/4 minus 2 7/8 is going to give me that missing piece. That missing piece right there, if we subtract. Even though it says how much more, we are subtracting, right? We used the example earlier of how many more years has one person lived than another, right? We don't add their ages together to compare two numbers, which is what we're doing. How much more we subtract, even though it sounds like we want to add. Okay, when you subtract these two, it looks a little complicated. They have unlike denominators, they're mixed numbers. My advice to you is to jelly bean it and change this mixed number into an improper fraction. Change this mixed number into an improper fraction. Then find common denominators and then subtract. So it's really 3 steps. You got to change the mixed numbers to improper fractions, find common denominators, and then subtract. Okay, if you don't remember how to jelly bean, there is a YouTube video on that. YouTube videos on everything. Okay, so that's the number 3. To make fruit punch, Tyrone needs 3 3/8 quarts of orange juice and 3 3/4 quarts of cranberry juice. How many quarts of juice does he need in all? Well, already I can see the light bulbs going on. You know that in all means to add. But if you want to think about it, if I have this pitcher, not picture, a pitcher of orange juice, that's how much orange juice I need. That's my OJ. And isn't my drawing beautiful? It's not, I know, but I'm watching Mr. Carrero's art YouTube videos. He's posting on YouTube, and I actually was able to draw the Van Gogh flowers this morning, so pretty proud of myself. All right, so 3 3/8 of orange juice, 3 3/4 of cranberry. I'm going to add those together. Once again, these are mixed numbers, so I probably want to jelly bean this one, turn it into an improper fraction, jelly bean this one, turn it into an improper fraction. They're going to have different denominators, so then I find the common denominator, then I can add my fractions. Make sense? Number 4 says, Lynn spent 5/6 hour on math homework and 1 3/4 hour on science homework. How many hours in all did she spend on homework for both subjects? Well, here we go. So 5/6 of an hour, 1 3/4 of an hour. She spent that much time on math, and that much time on science. We now know how much time she spent on homework in all. In all, we are going to add, okay? This fraction is not a mixed number, so I don't have to jelly bean it. I might want to jelly bean this one, and then I can find common denominators and add them together. Number 5, Sandra rode her bike 9 1/3 miles on Monday and 6 4/5 miles on Tuesday. How many more miles did she ride on Monday than on Tuesday? This is another one where they're trying to trick you. They're saying how many more, and when you cube this, you're thinking, oh, more. I usually add when I hear more. But they're actually comparing those two numbers. She's here on her bike. It's going to be a challenge. Isn't that an amazing bike? All right, there she is on her bike. She's riding along, and on Monday, she went 9 1/3 miles, okay? That was Monday. But then, on Tuesday, she only went 6 4/5 of a mile, so 6 4/5. She went more on Monday. We know she went more. They want to know how much more. So they want this missing piece right here. How much more is 9 1/3 than 6 4/5? And when we're comparing two numbers and looking for that missing piece, like we did on number 2 on the previous page, we can subtract. Okay. Once again, you are working with mixed numbers. So I suggest jelly bean, find common denominators, then subtract. Okay? Jelly bean, common denominators, subtract. All right. Number 6 is a question about estimation, because what I skipped in the beginning is they were asking you to estimate for these problems. For us, for my friends at Gome School 5th grade, I prefer us to just find the actual amounts when we're working from home on our own. Okay? So the question says on number 6, how can you make a high estimate for the sum of two fractions in a word problem? If you want to skip that one, if you are watching this video, I'm giving you permission to skip it. However, if you want to stretch your brain, think about if you're estimating, that means you're rounding. We haven't really worked with rounding and fractions, but think about 9 and a little bit more, okay? That would either be rounding down to 9 or rounding up to 10. When it asks you about a high estimate, it's asking you to round up. So that might help you figure out number 6. As if you're making a high estimate, if you're rounding both of them up, how can you do that? Like, say, for example, in this word problem. Okay? Hopefully that helped you set up your thinking for the word problems. Again, if you're having trouble figuring out how to change the mixed number to an improper fraction so that you can subtract or add them, or finding common denominators, hopefully the other videos will help you with that. All right, I hope you guys are having a great time. I really, really miss you.
You can't find a fighter, but I see it in you, so we gon' walk it out.